This is section 8.5. We're looking at trapezoids. Here's a example of a tougher problem. This is a trapezoid. You have a pair of parallel sides. You also have a pair of sides that aren't necessarily parallel but are congruent. This is an isosceles trapezoid. So we can mark down all the, what the heck? We can mark down, what is happening? Sorry about that. You can mark down all the things that you know. For example, the two legs are 6. I'm going to draw you a separate isosceles trapezoid. Let's just pretend that is an isosceles trapezoid. Here's your 4 angle measures of your isosceles trapezoid. Since you know part of that 116-degree angle up top is 25, that means the other part is 91. So I'm going to sneak up here, and I'm going to put these measures in here. This is how isosceles trapezoids work. That makes this little triangle isosceles. What I'm going to do then is I'm going to draw myself a big triangle where I know that's 64 degrees, and that's 91 degrees, and that's 6. And what I can do then is I can find the distance from P to A. I can find the distance from A to T. Okay, now they don't ask me for the distance from A to T, but isn't that going to be the same as the distance from P to R, since those are both diagonals? Okay, let me find little t first. That's segment PA. We know that little t divided by the sine of 91 has to be 6 divided by the sine of whatever that other angle is down here. I'm going to call that angle A on this triangle. What's left over? So we got 180 degrees in a triangle. We're going to take away 91, take away 64. This angle down here is 25 degrees. So across from that length of 6 is an angle measure of 25. Okay, now that's your law of sines. What we're going to do, make sure you're in degree mode. Make sure you have a calculator here, guys. We're going to cross multiply. So we're going to take 6 times the sine of 91. And we're going to divide that by the sine of 25. And this is going to give you your exact answer. However, I'm going to write it down rounded to the nearest hundredth. 14.20, I'm going to call it. Now the real answer is a little bit smaller. But that's the distance from P to A. So I got that guy. I can also find the distance from T to A. I'll call that little p. So if I want little p, let me just make a slight adjustment up here. If I want little p, I need to divide that by sine of 64. Now the other ratio, 6 over sine of 25, stays the same. So I can do 6 sine 64. Divide that by the sine of 25. That's going to give me 12.76 for this guy. And again, I have the exact answer on my calculator, but I'm rounding it. The real answer is a little bit bigger than that one. So now I have distance from P to R. The only thing I need now is the length of segment TR. That's the top of the trapezoid. So I'm going to have to draw myself another triangle. So to make some room, I'm going to clear out this trapezoid. And I'm going to draw myself this triangle up here. I know that angle's 25. I know that length is 6. And 25 and 91, what's that give me? Is that 114? Okay, so let's find this length. I'll call it little a. Since that's a capital T, that's a capital R, that's a capital A. And this angle up here, guys, is 116, not 114. So it's a good thing I caught that now. Did you catch it? All right, let's write ourselves another proportion. I'm still using 6 over sine 25. We know that works. If I want little a, I'm going to have to divide that by the sine of whatever angle is left over here. I'm going to use my calculator here since my brain didn't work last time. 180 minus 116 minus 25. That gives you 39 degrees for down here. That's the number that you put there. Okay, now I'm just going to cross multiply. 6 times sine of 39. It gives you a number. Let's divide that by sine of 25. And it's going to give me 8.93. It's not exact. The real answer is a little bit bigger than that. Okay, but that's how far it is from T to